In this problem, we're asked to solve the following system by substitution. Our first equation that we have in our system is x plus 6y equals 21, and our second equation says 5x minus 2y equals 9. So what you should notice about both of these equations is that they are in what's called a standard form. Standard form is when we have our x term first, then our y term second, and it's combined through addition, and it's equal to some constant or some number c. Now, in these examples, or in this example here, both of our equations are in what's called standard form. So it's not really all that conducive for us to be able to solve problems in standard form by substitution. So what we're going to do is we're going to go through and we're going to look at our variable terms like x and y in each equation, and we're going to see if any of those coefficients of those variable terms are 1. If they are, then we should be able to use that equation in order to help solve that equation for a specific variable. So if we look at this in our first equation, we have our variable term x right here that has the coefficient of 1. So I'm going to start off with that equation. I have x plus 6y equals 21. Now, what I want to do is I want to isolate this x, and I want to solve this equation for x. So in order to solve this equation for x, I need to get rid of this plus 6y. Now, I do that by subtracting 6y. Now, what I do on the left-hand side of my equals, I make sure that I do on my right-hand side as well. So I'm going to subtract 6y on the right as well. When you combine a positive 6x and a positive 6y and a negative 6y, it's going to give us 0. So what we're going to get here, what we're going to have left is x equals, and then we have 21 minus 6y. Now, you can leave that as 21 minus 6y, but what's more customary to do is to put your variable term out in front and then have your constant term as second. So I'm going to switch this around. It's a negative 6y plus 21. Now, it is perfectly acceptable for you to leave this as 21 minus 6y, but in most instances, most people, what they do is they switch that around and put that variable term first, and then they put that constant term second. So we have an equivalent equation here to our first one that says x is equal to negative 6y plus 21. So x and this algebraic expression are interchangeable. Now, what I'm going to do is I'm going to take my second equation, which is 5x minus 2y equals 9. And what I'm going to do is I'm going to find where I have an x, which is right here, and I'm going to replace that x with its algebraic equivalent, which is negative 6y plus 21. So I'm going to have 5. Now 5 was being multiplied by the x, so we're going to say 5 times this algebraic expression, negative 6y plus 21 minus 2y equals 9. Now, from here, what I need to do is I need to expand this quantity out. I have 5 times this quantity, negative 6y plus 21, and I'm going to do that by using the distributive property. So I'm going to take 5 times negative 6y, and I'm going to take 5 times 21. So when I take 5 times negative 6y, that's going to give me negative 30y. When I take 5 times 21, that's going to give me a positive 105. I still have this minus 2y equals 9 at the very end of this. Now, what I need to do is go through and I need to evaluate in this equation what I have and where it's located at in reference to the equals. So I have a negative 30y here. That's going to be a variable term. We have a positive 105. That's going to be a constant term since it doesn't contain any variables. We have negative 2y, which is a variable term. Then we have our equals. Then we have our number 9, which is going to be a constant term. So what you'll see in this equation is that we have two variable terms that both contain the variable y, and then a constant term on the left-hand side of my equals, and then I have another constant term on the right-hand side of my equals. So the first thing I'll want to do is I will want to combine this negative 30y with this negative 2y. And that's going to give me negative 32y. Then I have plus 105, which is going to be equal to 9. Now, from here, what I'm left with is a variable term and a constant term on my left-hand side of my equals, and then I have a constant term on the right-hand side. So what I want to do is I want to isolate, or I want to get this negative 32y by itself. That means I need to get rid of this plus 105. The way that I'm going to do that is by subtracting 105 on the left-hand side. Now, what I do on the left-hand side, I also have to do on the right-hand side. So when I take a positive 105 and a negative 105 and I combine those things, it's going to give me 0. The only thing I have remaining on the left-hand side of my equals is going to be a negative 32y. And that's going to be equal to the combination of 9 with a negative 105. Now, my outcome here is going to be a negative. And I have a positive 9 combined with a negative 105. I'm going to subtract the smaller of the two from the larger. So I'm going to have 105 minus 9. Now 5 minus 9, I can't do that. But I can borrow from what looks like a 10 here. So I'm going to mark out this 10. I'm going to make it a 9. And then I'm going to carry that 1 over, make it 15. So 15 minus 9, that's going to give me 6. And then I bring down the 9. So I have a negative 96 here. Now, negative 32y means the same thing as negative 32 times y. I want to get this y isolated. I want to find out what it's equal to. I want just plain y equals some number. So what I need to do is I need to get rid of this coefficient of negative 32 here. The way that I'm going to do that is by doing an inverse operation with division. So I'm going to divide this negative 32y by negative 32. What I do to one side of the equals, I must always do to the other. So I'm going to divide negative 96 by negative 32 as well. Now, the negative 32s are going to cancel each other out, and that's going to leave me with what y is equal to, or with a single y. Then I'm going to say negative 96 divided by negative 32. So a negative divided by negative, that is going to give me a positive. When I take 96 divided by 32, that is going to give me 3. So in this problem, our y is going to be equal to a positive 3. Now, the next thing I need to do is I need to find out what the x is. Okay, so I have a choice. I can either use the top equation or I can use the bottom equation to solve for x. It really doesn't matter which one you use, but in this example, it would be probably preferred to use the top equation because the x does not have any coefficients and there wouldn't be any extra steps in the top equation as there would in the bottom equation here. So I'm going to start with that top equation. I'm going to say x plus 6y is equal to 21. Now, I'm going to replace the y in this equation with what I found it to be earlier down here, which is y equals 3. So I'm going to say let y equal 3. And that's going to give me x plus 6 times the quantity 3, which equals 21. Now, from here, I'm going to combine this 6 times 3. I'm going to call that 18. So that's going to give me x plus 18 equals 21. Now, in order to solve for x, we need to get rid of this plus 18. We do that by subtracting 18 on both sides. When we take a positive 18 and a negative 18 and we combine them, we get 0. So we're going to get x equals 3. So our solution to this particular problem is going to be in an XY format. And the x of our solution for this is going to be 3. And then our y is also going to be 3. So if I was to try to make each one of these equations a true statement, I would need to replace the individual x's with 3. And I would need to also replace the y's with 3.